Okay, here we have our AVIT-DT, which is our desktop model. This is a 5x5 inspection and cleaning area. So here we have four Amphenol shell size 21, both socket and plugs that we're going to demonstrate. The first test we're going to run just one connector, and then we'll run some subsequent tests after that.
All right, here we are running the AVIT software. We're going to be testing with the FXT AVIT-11 fixture, which supports four mil-circular connectors, size 21. Each connector houses four MTs, some male, some female, some sockets, some receptacles. In this particular case, we're just going to be testing one, the receptacle socket connector. The first thing you're going to want to do is do an alignment whenever you first attach a fixture. Once you do the initial alignment, you shouldn't have to do it again for quite a while. As you can see here, the initial alignment from a previous test still shows that the connector is centered perfectly. One thing you're going to want to make sure is that the holes are centered within the green boxes, and that the fibers are centered within each of their individual green boxes. And as you zoom in, you can see that the fiber should be centered within there. There are controls over here on the right-hand side of the screen to adjust in the X and Y position. Also to zoom in and out. With the zoom in, zoom out button, you can do an autofocus. In this case, you use the box tool, select an area within the ferrule, and then select autofocus. It'll take a few seconds, and then we'll automatically focus for you. Now, since everything's centered, we're good, so we'll click OK. Next, we will select the test that we want to perform. We're going to, since this was a previous test, we can either test again, or we can select Test All, which will test all of the connectors on the fixture, or test subtest, which we can then pick and choose which connectors we'd like to test. In this case, we're just going to test the receptacle sockets, so we'll select all three of those. This will deselect them, and then this particular connector is the only one that will be tested. We'll select Start Test. And on the left-hand side of the screen, we can navigate through the various connector levels. In this case, it's the receptacle socket. This states its size, the angle of the key, and each of the MTs, A, B, C, D, and then the various fibers on each of the MTs. And here's the orientation within the connector. First, each connector is found using the fiber camera, the ferrule camera. It determines where the pinholes are, and then from there it determines where all the fibers are, then processes them. As the fibers get processed, they will either have a red box around them or a green box. Red box indicates that the fiber has failed one of the test criteria identified in the test configuration. The green box means that it's passed and has not violated any of the rules that were identified in the test configuration. Here you can see a green box versus a red box. Processing is going on in the background as fibers are acquired. This saves time, so the camera does not need to wait for fibers to get processed. once all the fibers have been acquired, the motion system will then send the camera onto its next connector or to its home position, which it is doing currently. All the while, fiber processing is ongoing, so that usage of time is maximized. And there we have it, 2 minutes and 39 seconds. Each fiber can be selected. The information can be displayed. As you see, there's one scratch identified here. With a width of 2.2 microns. Just one in total. We'll select a different fiber. Here you'll see several defects. In this case, there are the rule that it violated was rule number 5 for defects in the cladding. It was allowed 0, it found 1. So in that case, it failed. This can be done for each and every fiber located throughout the testing. And there we have it.